How to measure productivity in software development? There are plenty of opinions on how to measure productivity of software developers, but no single approach is accepted as standard. In economics, productivity is calculated as output per unit of input. We improve productivity when we increase output or reduce input. What is the output of knowledge work in general and software development in particular? People measure output by counting the number of features, user stories, story points, commits etc. or use source lines of code, SLOC, and function points. Instead of the physical output, we prefer to measure the outcome produced by the output. Outcome could be the customer perceived value, or business values such as increased revenue or market share. Could also be technical value to the developers, for example how easy a solution can be changed. What about the input, which is in the denominator? In software development people usually use time spent, capital invested or operational expenses, as the input for the productivity formula. However, all such inputs can be applied to manual work just as well. That is, because they don't account for what is unique to software development only, its essence, which is the acquisition and application of knowledge. Let's use a road trip as a metaphor. Say we are going on a short vacation with friends and family. Our desired outcome is to go to a place in the mountains and enjoy recreational activities. So in the productivity formula the numerator would be our desired outcome. What would we have in the denominator? We shall travel by car so it is useful and very practical to spend as little fuel as possible. The less fuel consumed the more efficient our trip would be. What would be the equivalent to fuel consumption in knowledge work in general, and software development in particular? Software development is a process of going from 0% knowledge about an idea to 100% knowledge of a finished product ready for delivery to a customer. Hence we can say that cars run on fuel, and software development runs on knowledge. The more existing knowledge was applied, or the less new knowledge was discovered, for producing the outcome, the more productive a software development process is. We know that knowledge discovered equals missing information acquired. Hence we can change our productivity formula to read: the less missing information acquired when producing the outcome, the more productive a software development process is. Missing information is studied by the information theory. Shannon's formula calculates the missing information, H, as missing information equals the average number of yes/no binary questions we need to ask in order to gain the knowledge needed. Software developers are engaged in a knowledge discovery process, which comprises of asking questions in order to acquire the missing information about what output to produce and how to produce it. How can we measure the missing information in software development? For that, we must be able to count the number of questions asked. However, there is no way to get inside humans' head and count the questions asked. For that, we turn to psychology where they study mental effort and cognitive load. Fortunately, there is scientific research that can help. It was done by Daniel Kahneman, who was awarded the 2002 Nobel Prize in Economics. In the 1970s Kahneman discovered that asking questions is an effortful task and humans cannot type at the same time. Now, what software developers actually do? Assuming they spend all their time working, then, software developers do two things only: typing and thinking what to type. Since humans can either type or ask a question, then we conclude. If there was a symbol not typed, then there was a question asked. Now we have a means to infer the number of questions asked during a knowledge discovery process. We introduce a metric called knowledge discovery efficiency, or KEDE. KEDE is a ratio between how much knowledge a software developer discovered for a time period, and a predetermined constant, representing an estimated maximum knowledge that could possibly be discovered for the same time period. KEDE is anchored to the natural constraint of maximum possible typing speed, and thus supports comparisons across contexts, programming languages and applications. When presented as percentage, KEDE has a minimum value of 0, and maximum value of 100. KEDE equals 0 when the missing information is infinite. That is the case when humans invent new things. KEDE equals 100 when the missing information is 0. That is the case for an omniscient being, like God. We would expect KEDE of 20 for an expert developer, who mostly applies existing knowledge, but also invents new things when needed. Now we can rewrite the productivity formula for software developers to have KEDE in the denominator. For example, if we have an outcome of $100,000 and KEDE of 2, then productivity will be $2,048 per bit of information. On another hand, if we have the same outcome of $100,000, but this time KEDE is 20, then productivity will be $25,000 per bit of information. We see the disproportionately positive effect of having experts on the team. If you want to apply KEDE in your organization, please visit the KEDEHub.io website.